Friends, a very good morning to one and all. Myself, Monica. Today, we will discuss about Cauchy sequence. First of all, we will know what is a Cauchy sequence. A sequence is called a Cauchy sequence if it is convergent sequence. Now, we will discuss this with the help of some examples. Sequence of 1 by n is convergent sequence. Therefore, it is Cauchy sequence. Sequence of minus 1 power n upon n is a convergent sequence. Therefore, it is a Cauchy sequence. Sequence of minus 1 power n is not a Cauchy sequence as it is not convergent. Now, let's discuss a question. Which of the following statement is true? Option A is every sequence that has convergent subsequence is a Cauchy sequence. Every sequence that has convergent subsequence is bounded. The sequence sin n has a convergent subsequence. The sequence n cos 1 by n has a convergent subsequence. Here, clearly option C is correct, which says that the sequence sin s has a convergent subsequence. Now, we will discuss with the help of some examples. Now, let's discuss option A, which says that every sequence that has convergent subsequence is a Cauchy sequence. It is false. We discuss it with the help of an example. We take example of sequence of minus 1 power n. Its range set are, its subsequence are 1, 1, 1 and so on, and minus 1, minus 1, minus 1 and so on. Its both subsequence is convergent, hence they are Cauchy, but the sequence is not Cauchy. Therefore, option A is false. Subsequence are convergent, but the sequence is not Cauchy. Subsequence are convergent, therefore they are Cauchy, but the sequence is not Cauchy as it is not convergent. Now, we will discuss option B, which says that every sequence that has convergent subsequence is bounded sequence. Clearly, it is false. We discuss this with the help of an example. We take an is equal to 2 if number is prime and the number itself if the number is not prime. Its sequence will be 1, 2, 2, 4, 2, 6 and so on. We will put 2 if the number is prime and we will take the number itself if the number is not prime. Its subsequence are 2, 2, 2 and so on, and 1, 4, 6 and so on. Clearly, its subsequence 2, 2, 2 and so on is convergent subsequence. But the sequence is not bounded. It is not a bounded sequence. Sequence not bounded. Therefore, option B is false. Now, we will discuss option C, which says that the sequence sin n has a convergent subsequence. Sequence of sin n is bounded sequence. And we know that a bounded sequence can have a convergent subsequence. But it should be not noted that every subsequence of sin n cannot be convergent. Therefore, we can say that option C is true. Option C is true. Now, we will discuss option D, which says that the sequence n cos 1 by n has a convergent subsequence. The sequence n cos 1 by n has a divergent subsequence because as n tends to infinity is infinity and it is divergent subsequence. Therefore, option D is false. Now discuss another question. Which of the following statement is false in this question? Option A says that every bounded sequence has a convergent subsequence. Option B says that every sequence has a monotonic subsequence. Option C says that every sequence has a limit point. Option C says that limit point of sequence is always limit of sequence. Here clearly option A is true. Option B is also true. Here option C is false and option D is also false. Therefore, correct options are option C and option D. Now, we will check option C, which says that every sequence has a limit point. For this, we take example of sequence of natural number. Here, clearly, limit point does not exist. Therefore, option C is false. Limit point does not exist. It contradicts option C, which says that every sequence has a limit point. Now, we will check option D, which says that limit point of sequence is always limit of sequence. For this also, we take an example of sequence of -1 power n. Its range set is -1, 1. Clearly, it has limit point. It has limit point, but it does not have any limit. It has no limit. It contradicts option D, which says that limit point of a sequence is always limit of sequence. Therefore, option D is false. Now, let's discuss another question. Consider the statement. Statement 1 is every sequence of R is convergent. Statement 2 is every convergent sequence is a Cauchy sequence. Statement 3 is every Cauchy sequence is bounded. Then, which of the following statement is true? We are given with 4 options. Option 1 is only statement 1. Option B is only statement 1 and statement 3. Option C is only statement 2 and statement 3. And option D is all statements are true. Here clearly all statements are true. So correct option is option D. Option D is correct. All statements are true in this question. Thank you and have a nice day. Please like, share and subscribe my YouTube channel.